Uh, hey everybody, what's going on? It's David Emily again. Wanted to do another Harvard CS50 walkthrough. Tonight it's going to be doing over Recover. So the idea here being that they kind of have a story behind it. It's kind of fun. You accidentally delete your pictures, your JPEGs, but you know, because you're a computer science or a programmer, that data is still written into the memory. So we create a quick program to go over, read out that memory, and rewrite it so we know where the JPEGs are. So we're going to be playing around with some bytes. Don't let this scare you. You've done a lot of the logic already. It's just at a different level. So instead of operating on stuff in memory, cache memory, we're now just going to be operating inside the file. So instead of stuff like printf, we're going to do writef, or fwritef, instead of... We'll find out when we get into it. Don't worry about it now. They tell us a couple things starting off. If you haven't watched this video, I definitely recommend it. The walkthrough is super helpful. They also mentioned some things about setting up some variables, so I'm going to do that right now. If I open up the code, the first thing they tell us about is they want us to define a thing called block size. So this is just saying that you're going to be working with the 512 size a lot. So they want you to go ahead and just set that up right off the bat. Since we're already up here at the top, I know I'm also going to be working with booleans, so I'm going to include the boolean library. With that bool standard, I have it standard bool.h. And then they also mentioned something about, let me pull it up over here. Setting this byte. So we can do type def. We can also just call uint 8t. So I think that stands for unsigned integer 8 bits. I don't know what the T is, like universal or something, so it matches on all operating systems. It's been a while since I've worked with this, but so that's another thing you can do. I'm just going to work with the uint t. I think that makes more sense than me just calling it a byte, but that's up to you. Do whatever you feel comfortable with. So the first thing we're going to want to do, but that uint is included in a library called standardint.h. So even if you don't want to use the type def, you'll also need to import that library. So starting out, one of the very first things, they give you a pseudo code. I kind of added to it just to kind of cover more of what we need. Let me make sure all this is still in function. Yeah, okay. So they're going to pass us a name in the CLI. You've been working with the command line already, so that's awesome. We're going to check it. We're going to proofread it. We're just going to make sure it's valid. If it's not valid, we want to return a 1. If it is valid, we're going to open it. We're going to read through it. We're going to work with something called a buffer. We're going to work with some file names. And then we're going to close all that and then close all files. But starting off, before anything else, before you start getting stressed about the file and stuff, let's just do what we've been doing. Let's parse that first thing. Let's make sure it's valid. So right off the bat, we come over here, and it's just going to be like we've done on our other programs. We're just going to check to make sure that the things they pass in, that they are only passing in one line. So that's going to be the if argc doesn't equal 2, because we have the first name, the name of the program, and then the actual argument. We want to print out. They have an actual saying, so I'm just going to copy that. So they want you to print out this, and then a return a 1. So that's just saying, hey, what we entered doesn't work, return a 1. And I actually think they have a test over that, so I'm going to build and pass that test. Oh man, let me do this real quick. Alright, so sorry about that. I don't want to show you all my credentials. But we're already passing 3 tests, and all we've written is 3 lines of code. So that's awesome. I dig it. Let's just keep going. We're on a roll. So next, since we're working, the thing they're passing in is a file. It's like a string. I don't know if this stuff's necessary, but I just want to make sure the second thing they're passing in like exists. So I'm just going to say if, I'm actually going to assign the file name here. So since we are working with a character pointer to a character array, I want that same thing. So character pointer, call it input file, equals argv1. And then I'm just going to error check this. So if for whatever reason it can't pull that out, I want to do the same thing that we've done earlier. So I'm just going to say if input file equals null. I'm literally just going to copy and paste this. So one thing right now is, because I just said I'm literally going to copy and paste that, that instantly makes me think of programming things called dry. So one of those is do not repeat yourself. So if we're doing it twice, I think that's a good sign for us to just have a method or a function that does it for us. So instead of just having this twice, I'm going to make a method that does it for me. We see here that we want to return a 1, so I'm going to make this function return a 1. So I'm going to say int, I'll call it input error for right now. It's literally just going to do this. So I'm just going to have it print and return a 1. So now here, instead of actually having that, I'm just going to say return input error. And then same thing for here. So now we only have to, if we ever want to change out what the input error is, we only have to do it in one place. It's still returning all the stuff. Let me build and make sure it's still passing all the tests. It's not, so input file declared here. Yeah, do you not like that? Did you mean use of undeclared input file? Oh, I did, thank you. So capitalization is important. RB, oh, and I've got those things confused. Okay. Run the tests. While those tests are going, I'm just going to keep going because I feel pretty confident with the changes we've made. We're just kind of extracting more. So now we have the file name. We want to try to open that file. So that file is actually going to be in here in the folder. So we can see here this card.raw. If we wanted to open it, we could probably open it in Vim. You wouldn't really see anything readable. Also, we able to pass these tests. So I think actually, if we go into it, I don't think it'll let you open it normally, but you can Vim into it, and it's. I mean, I certainly can't read this. If you can, you're probably in the wrong field. You need to be in like cryptography or something. Yeah. Anyways, not important. So here, since we're working with files, we're going to create a file pointer. So this is just going to say, instead of pointing like how a car pointer can point to a string, this is just going to be pointing to a file. So I'm going to say input pointer equals fopen, and then this is going to be the input file that they said. And since we don't care about writing to it at this point, we're only going to read. We are only reading from the input file, and we're going to end up writing to the output file later. So now that we have that, we also want to error check that this fopen actually worked. C, if you're ever working with C, it's good to just error check everything. And they actually say a different error for us to print out on here. Let me see if I can pull it up. So they want you to actually say unable to open that. So let me go to, so if input pointer equals null. So same thing we did earlier. If fopen fails, it returns in a null. So if that happens, we want to do printf unable to open file, and then we'll do the file name, or sorry, input file. So input file is a string we grabbed from up here, so we can do it here, and then return that 1 as the error. Kind of since I did this return input error thing and turn that into its own function, I'm just going to create this into a function too, just to kind of maintain what I've already got going on. It will take in a string because we're dealing with the input file. We want to print out the input file name so it looks really cool, but at the same time we're also still returning a 1. So I'm just going to copy and paste this. This is going to go up here. Since it's not an input error anymore, it's like a file error. I'm just going to say I call it file error. It's going to take in a string or a car pointer. It takes in an array. So file name, and it's a character array because in C, strings are character arrays. And I'm just going to print this. So here now, we're just going to return file error instead. I'm going to save, I'm going to rebuild, just make sure everything's still working, and then I'm going to run those tests. It is not working, so I mess this up. So we have use of undeclared input file. Well, I need to send in that right there because it's expecting a character. So let me see if that actually fixes it. No, it does not. Okay. 16, use of undeclared input file. Input file, so file name. I deserve that for copy and pasting. So we created this. I don't think it specifically tests for that file name being bad, so I'm just going to create my own test. Recover, don't open this. Unable to open file, don't open this. So this function is working. Sweet, awesome, that's all I'm going to do. I will run the tests just to make sure we're still working, but I feel good. And while those are running, I'm going to keep moving on. So now we have a file pointer and we know it's valid. So at this point, this is when we actually start running through that file and printing out stuff we need. To do that, we're going to need a bunch of things. The code kind of goes into it. Okay, we're still failing the thought about rebuilding the JPEGs, that makes sense. But so we want to initialize a couple things. So if you read over the intro, we need a buffer, which is going to be the uint8 that we kind of touched on. We're going to need another file pointer, which is going to point to the file we're writing to. We need a counter to keep track of how many JPEGs we have, so we know where in the file to be writing the JPEG size. And I think that's it. No, we need to keep track of the file name we're doing also. So while I'm there, let's just start with that. So let's call it car array file. So file name. And according to the documentation, we want this to be 8 characters. So the reason we want that is because this is actually going to end up being dot and then dot JPEG. And then because it's a character, or because it's a string, we need to include the null terminator. So that's why it's 8. If you count this up, 1, 2, 3, 4, 5, 6, 7, and then this is 8. So that's why we need 8 there. We mentioned we need another file pointer, so I'm just going to call it output pointer. I'm just going to set it to null right now because it doesn't need to point to anything. We need to have the buffer. So this is going to be this block size, and it's going to be a byte array. Here I'm just going to use the uint 8t array. So this is going to be Let me make sure I'm doing this right. Uint at, yeah, okay. Uint at buffer, and then the block size. So this is just going to initialize this. We're going to read from the file to put into the buffer, and then use the buffer to read into the output file. So we've got name, output, and buffer, and then a counter. So I'll just call it JPEG counter. I guess I could do, no, that's right, okay, cool. And so now we've got everything initialized, we actually want to go into the file. So if we look at the pseudocode, it recommends read until the end of card. There's a couple cool things we can do. I think the CS50 recommends something called EOF, which is end of file. So FEOF, which checks that your endpoint file, if it's pointing at the end of file, it'll return a 1. Elsewise, it returns a 0. So if there's more stuff going on there, it'll return a 0. If it's done, it'll return a 1. So if the input file is at the end of file, it's going to be true. And in C, true is 1. But there's also a thing we can do. The actually thing we use to load the buffer is called fread. So up here, I'm actually in print. Oh man, my internet is slow. Okay, I'm not going to worry about that too much then. So we're going to do a thing called fread. And fread, if it's successful, it will return a 1. If it's unsuccessful, it will return a 0. So I'm actually going to use both of those to create a while loop. The pseudocode they give you only mentions the end of file, but you're going to end up freading anyways into the buffer. So instead of just error checking that, I'm just going to include my error check in the loop. So I'm going to do a while, and we're going to do fread, and we're going to want to read into the buffer the size of the uint t8. I should just call that byte. I would have saved so much time if I did that. So that's going to be telling, like, the buffer we're going to load in byte by byte. This is going to be the block size, the 2512 that I talked about, and then this is going to be the input pointer. So while it can read from the input file into the buffer, this wants to work. And then we also want to do, or that the input pointer, our file we're reading from, that it does not equal the end of file character. So while those two things are going on, we're good to read from the file. And then basically what we want to do is we want to read. If we see it's one of the JPEG names, we then want to create a JPEG document in our file to copy that into. If it's not a JPEG header, we just want to keep writing. So we keep writing until we see those headers, in which case we create a new file. So they actually give us the math to figure out this. So it's going to look like this. I'm going to go ahead and put this into a function as opposed to just running this every time. But we kind of talked about it earlier, and so coding by intent, I'm going to kind of code out what I want to do and then just go in and incorporate it. So I'm going to say if I'm on a header. So if is JPEG header. I want to make sure I spell JPEG right in all the ones. So if JPEG header, that'll be the buffer. I want to go into the statement. Else, I just want to keep reading. So this JPEG header, I'm going to do the math we did earlier, and I'm going to create another function up here. So instead of just having that buffer check in every single line, I'm going to export it into a function. I just think it's easier. So we're going to use the bool. I'm going to say if is JPEG header. It's going to take in the uint 8t buffer. And then I'm just going to post that logic here. Let me recopy that logic. Okay, and then so just, oh, I don't like that. Oh, no. Keyboard shortcuts, why are you failing me? So just return this. Okay, so that'll return a true, which is awesome. So if this is true, go into here. And this means we need to create a new JPEG file to go for it, to build this out. So if this is the very first time this is running, our output pointer, file pointer here, is going to be null because we set it up here. So we don't need to close it. Actually, I'll just come back to that real quick. So let's just start this off. So we're going to do called sprintf. So secure file print, I'm pretty sure is the name. We want to print to the file name that we're creating. That name can be anything as long as it follows that convention. As long as it ends with the .jpeg and it starts with an 03. So I'm just going to use an I because I think that's cool. And then the JPEG counter. So this is going to print along there. It's going to create a name. We're going to call the output pointer equal to the, it's going to fopen the file name that we just created. And we're going to set it to write because we want to write to our file. And then we want to increase our counter. Okay. And one thing I mentioned before is this is going to work on the very first time we go through because this output pointer is going to be a null. So it's going to be easy to fopen this. We cannot fopen on a file pointer that's already open. So we need to incorporate some logic that if that output file pointer is already being used, output pointer. Ooh, that could have been bad. That could have been bad. So if that's already being used, we need to close it. So I'm just going to incorporate a line in here saying that if this equals null, close it. So then first time it runs, it's going to run this. Every other time it finds the JPEG headers, it's going to run that. It's going to close it and create a new one. So that's the entire writing over, or the entire creation of the new JPEG in the new file. Now we want to copy over the actual writing. So actually that's not going to be an if because I want to reuse that. So here I'm just going to say if output pointer, I think it's on my clipboard, doesn't equal null, then we just want to write. And the way we're going to write is up here we read this information from our input file into the buffer. We now want to write it from the buffer into our output file. So to do that, we're going to call it, it's called fwriteF, or just fwrite. We're going to write the buffer, so that's where it's coming from. The size of information we're moving. And a lot of this I'm kind of just jumping over. It's in this printf, so it goes into fprintf. So the stream, the character, the size. So really, if I name a method that or a function you're not familiar with, I recommend looking at the CS50 file main page. Right now I'm just trying to blow through this. This is kind of under the assumption that you've read the course, you've read the walkthrough, and you're pretty familiar with the functions. You just want to see how other people have done it. So we're reading from the buffer, the size of the buffer. We're going to move one size of that, and we're going to write it into this output file. Okay. So while we can read from the input file, and while the input file is not its last one, if we come across a JPEG header, we want to create a file name, and we want to increase that JPEG to keep track of where we're in the document. The second time through, or second and on, this output pointer will be loaded, so we want to close it. So this will create a new one. If the output file, if we are looking at a output file, we want to write to it, and we want to write from the buffer. So that's going to load that. So all the logic we have here on our thing is done. So we did it a little bit differently. There's some overlap here. What I did was I took this write new JPEG, and I took this out, and I instead put all the writing here. So this is going to now it's only going to handle the creation of the documents, and then I have another step for actually writing it. So this end of memory card is our while loop conditions, and now we want to close all open files. As I mentioned here, these F pointers, we need to close them before we can do anything with it. C is kind of funky in that it doesn't have garbage collector, so anything you create you have to close or you'll create memory leaks. So here, kind of how we F-close this, if it existed, we want to do the same logic. So if output file is not null, we want to close it. And then also we want to do the same for our input pointer. So if our input file, if we still have a pointer to it, we want to close it. I don't know of any reason why we wouldn't have those pointers existing, but I want to include these nulls just to, I guess, error check more. One thing I learned from a lot of my undergrad and working with C is just always error check it, because it is not friendly to handle errors. So cool. Let me see if this builds. Well, we did a lot of work, so I don't think it will. Yeah. So here on line 48, I have lowercase nulls, so that needs to be uppercase. Cool. On line 60, not used by format string JPEG counter. What did I do earlier? I'm pretty sure that needs that. And JPEG counter, incorporate that, fsprintf. File name, JPEG. Oh, I need, sorry, I need to do that. To tell it that it's going to be using this as a 3 integer thing. So this can be an I or a D. Sorry, this is just a formatting string saying that it's going to take this and format. If it's a 1, it's going to turn it into a 3-digit number. So just formatting. And then here on line 66, implicit definition of size. Oh, what is that? Is size? Size of. Size of. Okay. Stop. Okay. Sweet. So let's try this again. Wow, Bill, I'm surprised I didn't have more errors. So let's run these tests. Oh man, okay. So let's run all the tests. Unfortunately, the way I did this project, it was pretty hard to work incrementally through the different tests. I think that's the best way to go. And right now, I deserve all of what I'm getting because of that. So I'm currently having a seg fault. So I'm going to take a quick look over what I may be doing. So I'm F-writing this. I have the buffer. I'm lucky enough that I did this earlier, so I can look at my other what I have. So if I'm having a seg fault, that makes me think that our end condition is not working correctly, and that we're going over the block size that we have. So that makes me either think that I have a file pointer wrong or a buffer pointer is wrong. So block size, input pointer, so that looks right. That looks right. We have, if it's a buffer, send that, cool. Check up here on the buffer, we operate on 0, okay. So that looks right. We create this. Oh, well there's the reason, because that needs to be not null. Yeah, okay. So by this equaling null, it was, I just, backwards up. I don't want to close it. I can't close it if it's null. And the way I had it was only closing it if it was null. So cool. That is recover. So just to recap, we error check what we pass in. We output some errors. When we get here, we have an input file, a buffer, and an output file. We want to read the file into the buffer, and then read from the buffer into the output file. We want to, for every time we're reading the input file and we come across a JPEG header, we want to create a new file and then print that over. So we broke that up into dealing with the JPEGs and then dealing with the writing. And that's recover. So thank you for joining me. Hopefully, that wasn't too bad. It's really late right now. I ended up working late for work and I was already here, so I just wanted to knock this out. But thanks for joining me. Thanks for doing Harvard CS50 and sticking this out. I know this problem, reading it, is kind of complicated, so hopefully watching me walk through it kind of made it seem less complicated. I don't know. Tell me what you think. Tell me if there's any comments, any ways to improve. Please don't be too brutal. I'm a softie under all this, but I appreciate any criticism. And until next time, keep coding.